So hello everyone. In this video we will see basically what is a half adder and we will simulate the same on Tinkercad. So let's start. Basically half adder is something in which we add two bits and we get the output in the form of two outputs. One is sum and one is carry. So here we have two inputs A and B and two outputs sum and carry. We add 0 and 0, so we get nothing as the sum, and that's 0, and we did not use carry, so the carry is also 0. Now the inputs are 0 and 1, so the sum becomes 1 because 0 plus 1 is 1, and we did not use any carry, so it still remains 1. Then the inputs are 1 and 0, and the sum again becomes 1 because 1 plus 0 is 1, and we did not use carry, so it still remains 0. When we add 1 plus 1, so here mind it, we are adding binary bits, so 1 plus 1 in binary is 1 0 because we cannot write 2 in binary, so we write 1 0 for 2 in binary. So the sum is 0, which is the least significant bit in the 1 0, and the carry is 1. So 1 plus 1 gives us carry as 1 and sum as 0. So if you notice, the sum here is same as the output which we get in XOR gate, and the carry is here same as the AND gate. In XOR, when we get inputs same, so 0 0 or 1 1, the answer or the output is 0, and when the inputs are different, the output is high. And in carry, all the outputs are 0 and the output is high only when both the inputs are high. So now let's see the K map. For carry, we have plotted the K map, and we can write the equation here simply. Carry is equal to A dot B, or we can say A and B. And for sum, we have again plotted the K map, and we have written the equation as A B bar plus A bar into B. So this is same as XOR gate, and this is same as AND gate. So now we can take a look to the logic diagram of half adder. So here it is. We have two inputs A and B. For sum, we use the XOR gate, and for carry, we use the AND gate. And then we can implement this on our Tinkercad simulation platform. So we move towards the Tinkercad window. What all we need is the breadboard for placing the ICs, one power supply for giving the power. We also need one DIP switch because we need to change the inputs. We need to switch them between high and low. So we take a switch. We need two LEDs to take our output. So we type here LEDs and we take two LEDs. So we also need two resistors because LEDs won't be able to handle such high voltage. So 330 ohms would be a good number. We connect the LEDs with the resistor at the cathode, and we give the cathode the negative terminal. Similarly for this also. So one from the two LEDs will act as the sum and the other will act as the carry. We are only using two inputs, so we will use two switches, and both we will give them high inputs so that we can change the inputs according to our convenience. The positive terminal from the power supply will be given here, so that all the green circles visible here are the same points basically. So when I connect this to the positive terminal, all these points are connected to the positive terminal. Now the negative terminal. When I connect one point of this line with the negative terminal, all these points are connected to the negative terminal. Now we need one XOR gate and one AND gate. So we search here XOR and we place it here. We need one AND gate, so we search AND and we take the AND gate. So be careful here because there is also a NAND gate here and we do not need that. We need AND gate. So that's it. And now in ICs we need to give them power at the 14th pin. So there are 14 pins in both of these ICs: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So the 14th pin will be given the high power, and the 7th pin of both the ICs needs to be grounded. So we will connect them with the negative terminal. Similarly, all these green circles are the same points. So even if I connect this point to negative terminal or this point to the negative terminal, it means one and the same. So now we have given power to both the ICs and we have also grounded them. And now we need to take inputs here. So here for the XOR gate, you can see the name appearing here. There are two inputs, one A and one B, and from this pin we will get the output of XOR. So we connect here the two inputs. And one. Okay, so we gave two inputs here from two different switches. Here, no. Okay, sorry. The input 1A is taken from the first switch and input 1B is taken from the second switch. And now we will take the output from here, output 1 pin, and we will directly give it to the anode of one LEDs. Now this will act as the sum because sum is XOR. And now for AND gate, input 1A and input 1B, we can take the inputs from the switch as well as we can take the inputs from here because all the points here are same as the input 1. So we can also take it from here and give it to the input 1A and the second input from here, and we can give it to the input 1B. We can also take it the input from the second switch and the first switch, but we can also take it from here because all the points are same. Now the output we get here is for the carry, and we take it and we connect it to the anode. So basically our half adder is ready, and now we can name it. Here we give sum, here we take carry, we can name it as sum, and here carry. So we can start simulation. If there is some error, we would resolve it, or else what we have made is our half adder. So let's start. The inputs here are low because both the switches are open right now. So let's start. For 0 0, the input 0 0, we get the outputs low. We can use the truth table to verify. Now the second input we give here is 0 and 1. So 0 and 1. So sum is 1 and carry is 0. So sum is 1 and carry is 0. The LED glown shows it is 1. The output is 1. Now for 1 and 0, again the sum becomes 1 and carry is 0. Similarly, we can verify it from the truth table. 1 and 0, sum is 1 and carry is 0. For the last input, A and B both are high. So A and B both are high. So sum becomes 0 and carry becomes 1. And we can verify it from the truth table. So we have verified it from the truth table, and we have made the circuit for half adder, and this is what it would look like. So thank you for watching this video. Please like, comment and share. So hello everyone, in this video we will see basically what is a half adder, and we will simulate